Okay, welcome to our next unit, next lesson, sorry, in our unit. Today we're moving more into how to analyze and interpret, and now we want to create our graphs given situations. And so in this instance, when given a description or a visual representation of a situation, I can sketch the graph that shows the important features of the situation. And so today we're practicing how we can sketch our graph so that we are describing our situation. And so no new vocabulary today because we're really applying what we've done through lesson 6 and lesson 7. And so first activity goes into which one does not belong. So click the graph where you think it does not belong and explain what you are thinking. As always, this is a time to develop your language, and they all don't belong for different reasons, so there's no absolute correct answer here. In the first activity, you are looking at a flag being raised in the flag ceremony held on 4th of July. The height of the flag is a function of time, right? We're looking at the height of the flag as a function of time. As you can see in these tiny boxes here, these are 3 different graphs that can represent our function, which is a function of the height of the flag per the time. And so we want you to start describing what does this situation mean in context. And so in this case, if I was looking at graph C, I know that the flag starts out on the ground. If I choose number C to do, I know that the flag starts off on the ground or at 0 feet. If I want to follow the specifics of this way, I know that it starts off on the ground and it starts to thinking about what we talked about with rate of change last lesson. It gets pulled up quickly, right? It's going up very fast. It's getting pulled up quickly and gets pulled up quickly. Then after it gets pulled up quickly, we can see that it starts to level off a bit, right? It doesn't from around 1 to 2, it doesn't really go that much higher. It kind of hangs around 2 feet. And so it gets pulled up quickly, then it slows down, then the movement of the flag slows down. Flag slows down. And at some point, then it starts to raise up very quickly, right? All of a sudden it slows down and then it gets pulled up very, very quickly from 2 to 3, right? Flag slows down at around 2 and 2.5 seconds, right? 2.5 seconds. We see that the flag gets raised quickly once again. The flag gets raised quickly once again. Right, we want to describe what is happening in this situation. We've been practicing this with lesson 6, but how can we use that to further describe our graph? And so you want to do this for this slide, and on the next slide, right, choose another graphical representation and explain what's happening with our graph. Then you want to think about, okay, in this situation, what is the most realistic out of our 6 graphs, right? Which one seems like the most realistic option for when I'm pulling on that flag wire to raise my flag? So think about what each of these situations actually look like in real life and how you can describe that. And so one other thing I want you to think about is going along with the realism is that, can I have this situation as my graph? Can I have a graph that looks like this? And tell me why or why not. And this goes into what we were talking about in our first lesson of what defines a function. And so in the next part, you went from graph to situation, and here you're going from situation to graph. And so you're going to click on these links and watch the videos of a flag being raised. I'm not going to play all of it, but you're going to play a video of a flag being raised. You are going to have a time stamp here for you to help you sketch your graph, and that should help you in creating your graph for the situation, right? We have our time in seconds, we have our height in feet, and remember, this is just a sketch. So it doesn't give you the height, but how can you estimate what the height is going to be? And so if you need it in full speed, it is over here. If you need it in half speed, it is over here. And when you're sketching your graph, right, if you have your sketch of your graph, let's just say this is your graph, this is not a correct sketch, you can use that to help you find your average rate of change. Average rate of change comes from lesson 7. So if you need to go back and look at the lesson 7 summary, take a look at that. But remember, when we're creating our average rate of change, we choose 2 points on our graph. I'll try a different color. We choose 2 points on our graph, and we use that to help us create our average rate of change. How quickly is the flag being raised in the situation that I'm talking about? And you want to be specific, right? When is this happening? And so we want the average rate of change for when the flag starts moving up, which is at what time, and then when it stops moving. And so where do those things happen, right? This is the key part. We want it from the time the flag starts moving up to the time it stops. So it's not any 2 points. You're looking for when it starts moving up and to when it stops. So you want to have your correct graph, of course, as you're going through that. Last but not least, the last activity goes through giving you a description and wanting to find creating the representation, right? To prepare for a backyard party, a parent uses 2 identical hoses to fill a small pool that is 15 inches deep and a large pool that is 27 inches deep. The height of the water in each pool is a function of time since the water is being turned on. You want to sketch the graph on the side of 2 situations, but of the 2 functions, so that S of t is the height of the water of the small pool and L of t is the height of the water of the large pool. So in this situation, you're creating 2 different functions on one graph. So let's see. Each hose fills one pool up at a constant rate. We know that a constant rate is a linear function because it's filling at a constant rate. And so when the small pool is full, the water for the hose is shut off. Okay. And the other hose keeps filling the pool until the larger one is full. So let's do one at a time. So each one is being filled at a constant rate. So let's start off with my small pool being filled up at a constant rate. I know that the pool is full when it gets to 15 inches deep. So I'm increasing at a constant rate until I have 15. Once I hit 15, then I know that the hose is shut off, so it will not exceed that 15 feet. Same thing in this situation. If I have a large pool, right? This is my small pool, this is my S of t. If I have my small pool, I can take a look at my my large pool is increasing up at a constant rate, and I know that it fills up at a height of 27 inches. So if it's filling up at a constant rate, all the way up to, and that should be a straight line, but my hand is shaking, all the way up to 27. Once it fills up to 27, the hose is shut off. And so this is my L of t. And so you want to use that to help you create your 2 graphs in this situation, right? In this case, each hose fills one pool at a constant rate. When the small pool is full, both hoses are cut off. So what does that represent? And how can you use that to help you graph? And so last but not least, of course, we have our lesson summary, summarizing how we can use our graphs, our descriptions to help us graph, and our graphs to help us create our descriptions. And so I will see you finally in lesson 9, which wraps up this part of our graphing unit. And I look forward to seeing you in lesson 9.